In this third part in the steering series, we are going to pimp up the game, adding that little goal that we can set by clicking and that our AI will follow using the arrive steering behavior. To learn how to code follow and arrive steering behaviors, watch the previous two parts, links in the description. But without further ado, let's get started. We're going to make that target arrow separate from our AI agent. Let's say a bit as if we were making a strategy game. So we're going to create a new scene for that and start with a custom node, an area 2D. Why is that? Well, it's going to detect when the AI hits that area 2D, and when it does so, the cross is going to disappear, indicating that the AI reached the goal. Even though it's really UI, it's disconnected from the AI's movement. Let's call that our target. Could call it the target cross or something, whatever you want. And click and drag the target sprite on the canvas. It's in the assets folder. Add that new sprite. Let's double check its transform in the inspector, that it is on the origin of the world. And then we need some collision shape for the area to be able to detect the AI. So select the target node, press Ctrl A or click the plus button there to add a collision shape 2D. In the inspector, in the shape slot, let's add a circle so that we have a circular area that can interact with the player. That's not all we need. We need to go back to our area 2D node and set it to only detect our AI. So right now, our AI agents, if we select them, go to the physics body 2D collision category, we'll see that they are on layer 1. That's I called player. It should be units or AI, really. They are on layer 1. So our area 2D, you go down to collision here, under the area 2D section, and they won't be on any layer. Nothing is going to detect that UI element, but this UI element will mask the first layer, meaning it will detect everything that is on that layer, like our character follow and character arrive. What we're going to do as well is animate it. We're going to make it fade in and fade out. So to do so, select the target node, press Ctrl A to add an animation player, the first option. With that, we want to save our scene. Ctrl S, go to the source folder, create a new UI folder, for example, and let's call it target.tscn. From there, we can create a new script. So click the new script icon. It will automatically create a target.gd script. Set the template to empty as always. The default one is annoying, to be honest. Click create and voila, we can get started coding. We are not going to write code just yet. Or actually, we are going to, using the animation player. This might sound surprising, but using the animation player is a form of programming. Let me explain. You have your node here, and we want to make it invisible when the player hits the collision shape, or when an AI agent hits the target. You could do that using written code in GDScript with a line like visible equals false, assigning the false value to the visible property. This is similar to clicking the little eye icon here. The animation player can do that as well. You create a new animation, let's call it fade out, because we're going to add fades as well. This is why otherwise it would be faster to write code. Allow me to zoom in a little bit on the track, because we're going to make it fairly short. We're going to add a track, a property track on the target here, and we want to look for visible. Right click to insert a key at the start, and let's make the fade 0.3 seconds or 0.4, something like that. Insert a key there as well. And now we can start with a fade out with the object visible. And after 0.3 seconds, we're going to make it invisible. So click on the little checkbox here, and in the inspector, set the value to be off. This is a declarative way to code. It describes what the animation is about, and at a glance, you can see everything that is going to happen. We are fading out. We have a label for this. Well, if we were creating a method, it would be a little more complicated to make it turn invisible after 0.3 seconds. You would have to do something like that. Write a function, fade out, let's say, and it doesn't return anything. We would have to say visible equals true in this case, then get the tree, create a timer of 0.3 seconds, and we would yield on that. So we would use the yield keyword that allows us to stop the execution on that line, on line 6, until an object has emitted a signal. Pass the timer, this creates a new timer, and then we would have to pass in a signal, the timeout signal from a timer. So we would set the visibility to true, wait for 0.3 seconds for a timer to time out, and then we would set visible to false. This is called imperative programming. This is what you are doing most of the time when you write GDScript code. You are describing every step the computer has to take to make calculations, to make something happen. With the animation, you do not have to care about that. With time-based operations, it can be quite convenient to use the animation player. On top of that, compared to writing code, the animation player has one obvious advantage. You can visualize the animation in the editor. Let's make the animation 0.3 seconds long, and we're not just going to make the object invisible. We're going to add a track, property track, on the target this time, just on the sprite, and we're going to animate its modulate or self-modulate value. So let's insert a key at the start and insert a key at the end. Select the white color here, and for the value, you want to turn the alpha slider down to 0. You can see a gradient from the start color to the end color, showing you how the object is going to disappear slowly. Now press Shift D to play the animation so that you can see what's happening. You can make the collision shape 2D invisible to see the transition a little better. We can also tweak the timing of this transition. So we could extend, shorten our animation, but we can also select the first color and change the easing. If you pull it to the left, the jump from the white to transparent will be a bit faster. If you make it go to the right, like so, the value will go slowly from the start color to the end color and accelerate. It will stay white for longer, and it will jump to transparent a bit faster. So we want to make it the other way around, to bump a little bit. It depends on how you change the easing. Sometimes you want to select the keys and extend the animation a little bit, to 0.4 in this case. Because as you change that, as you accelerate the start of the animation, the timing starts to feel a bit different. Anyway, we have our fade out animation. We are going to add another one by duplicating our animation to make the object fade in. So click the animation menu and duplicate the animation. It's called fade out copy. We want to rename it to fade in. Like so. All we want to do for this one really is select the keys and kind of invert them. So we are going to do that. Click and drag to select several keys at the same time. Click and drag on the keys to move them on the editor. Not the visible one though. We only want to have one key at the start that makes the object visible from the start. It has to be visible, rendered on screen, but on the first frame, it's going to be fully transparent, right? So we can use animations like these to get started. Well, I'm going to jump back to our target script, which I'll expand move these out of the way, and we'll start by getting a reference to our animation player. So I'm creating an onReady variable called animation player that will store our animation player node here so that we can ask it to play animations at runtime. Then we have to do a few things regarding signals. We want to detect when something hits the target, something hits this collision shape. So on the Area 2D node, if you go to the Node tab in the inspector or next to it, you have a body entered signal. When a kinematic body 2D, like our AI agent, is going to hit the area, this signal will be emitted. We want to catch it. So we can do this from the code like so. We, in the ready function, call the connect method. We pass it the signal we want to connect to, body entered. We connect to this object, self, and we're going to call back a method named onBodyEntered when that signal was emitted. We're going to add that method right now. You have to respect the parameters that this signal is going to pass. So you want to create a new onBodyEntered method. It's going to take a body parameter. That's from the signal definition. You want to control click on Area 2D and go to the signals to see body entered and the parameter that it passes you, because you have to use the same in the callback function. And when a body hits the character, we're going to ask the animation player to play our fade out animation. It means an AI hit the target, we want to fade out. When are we going to fade in? That's when the player clicks somewhere. Clicking will set the target for the AI. To do so, we're going to use the unhandled input function, like so. This is a built-in in Godot. It's going to be called every time the player uses an input, presses a key on the keyboard, if the click action is released. Not when you click down, but when you release the click, we're going to play fade in. You can also change it to on action pressed. Try the two in your version of the game to see which one feels better to you. Now we are going to do something a little more than that, because if you play the game now, so I'm going to go to the game and add my target scene, target.tscn. So I'll click and drag it at the top of the game hierarchy, move it a bit in the view. If you click and release, you are going to see it not move. We want it to go when we click. And we want to do this continuously so that if you just click once, it's going to jump to where the mouse cursor is. But if you click and drag, we want it to do like in the editor, to follow the mouse cursor. To do so, we have to use physics process. So I'm going to add the physics process function. And to detect a click on every frame, we're going to use the input autoload, the input class. Instead of using event, the parameter passed to unhandled input to access input, we can access it anytime through this input class. And you have access to the same method. Is action pressed? Is action released? The thing is, if we put it here in physics process, 60 times per second, it's going to check that the click is down on your mouse. And if so, it's going to update the global position of our target to the mouse's global position. Press F5 to play the game to see how, now if I keep the click down, it moves along with my mouse cursor. Now we have to add one more thing at least to limit bugs here. It's to set the visibility of the arrow to false by default. Until we click, it shouldn't be visible. And the reason we're doing that is because when you work with the animation player in the editor, like so. One thing that will happen is the state that you leave the object in here is going to be the state that gets saved when you save the scene. So sometimes you want to just safeguard, for example, the visibility of the node in the script editor. Because if I were to set it here, right, to invisible, save, as soon as I move somewhere on the animation, the node becomes visible again, which we do not want. At the start of the game, we don't want it to be visible. Okay, so we have our arrow. The AIs mindlessly follow us around. But now you're going to see some weird bugs with our fade in and fade out animations, right? When the AI hits the arrow, it does fade out properly, but depending on when we click, the arrow blinks a little bit because it restarts the animation every time, which is not what we want. We want it to fade from the current transparency level. The animation player in Godot 3.1 gives us a feature that allows us to get that kind of for free. It's called the capture mode. This is on the right side of the animation player in this area that you can set it with this element here. This little curve indicates how the curve is going to evaluate. So continuous means update the value on every frame, not just on every tick as when we are dragging on the timeline, but every frame in the game. Discrete here means only update the value when you hit a new keyframe. In this case, for visible, it's set once at the start, and then it's not set on every frame. It's only once. We have a mode called capture. Capture is going to do a fade from whatever value you have at the start. So if you set a start keyframe and an end keyframe from your animation, it's not going to do anything. But if you remove the first keyframe, it's going to reach the white color from whichever color the node started with. And go to fade out to do the same thing. We want to fade out to transparent from whatever color the modulate value is, and we want to set the curve to be in capture mode. Now play the game again, and you can now see that if we click many times, the animation re-triggers every time we release the mouse click, right? But it's only going to fade from where we are. And if the AI hits the arrow, it's going to fade out. Note that if you have the arrow that is over the AI, sometimes it will not detect the body entering because it is already on top of the area. Remember that the signal is body entered, so it only works if the body entered the arrow. You don't want to create the arrow maybe if the AI is already on top of it. I will let you add that to your code as a little challenge. The last thing we have to do is make it so our arrive to AI only goes to the target when we click. So for that, it's disconnected from our target node here. Select the character arrive, open the script. Let me expand the editor. And where we were making it always follow the mouse position, we're not going to do that. We're going to store that position when we click, like so. Using unhandled input, we're going to check if event.isAction pressed, click, so that when we click, we're going to set the target global position to mouse position. We want to remove the var keyword here so that we can create a new variable, target global position, and create it somewhere around here above our velocity variable. So we're going to create that, and it's going to be a vector2, starting with vector2.0. Then what we're going to do is make our object only move when we are too far from the target global position after we clicked. To do so, we're going to deactivate physics process at the start of the game and reactivate it when we click, like so. We create the ready function, and we're going to set physics process to false. you can copy that line with Control-C and paste it down there. Oh, I forgot to remove the hint here. That's why I was getting an error. Now, when we set the global position, we set physics process back to true. I'll scroll down a little bit, which is going to start the physics process loop. It's going to hit that line. If we are too close to the target, we're not going to return. We're going this time around to set physics process to false. Let me copy the line again, paste it there, set physics process to false. And with that, our arrive to AI is not going to move at first. Only when we click, it's going to head to our target arrow. Now it's not continuous. It's only going to where we first clicked. So we also want in physics process to update that position. So we're going to copy our line. If event is action pressed, update the target global position here. We're going to put it at the top of our physics process function. If input, this time that is action pressed, we have to use the globally available input class. We're going to update the target global position until we stop physics process. I'm going to remove the follow character for now so that it doesn't annoy us. And we only have the arrive to character to work with. So you click, it goes somewhere. If you click and drag, it updates its position constantly until it hits the arrow that's going to disappear softly when the character hits it. Now for the arrow, I've made it only appear when we release the mouse click. You can change that to only to appear as soon as we pressed the click. Okay, with that, that's it for this tutorial. I think that's enough. We have the character or the AI that can make the target arrow disappear. There's one small thing, a little assignment for you. The first time we click somewhere, the arrow plays a fade in animation, but it appears instantly as fully transparent. You have to figure out why and fix it. Please tell us in the comments below how you found the solution. But with that, for now, I'm going to say thank you kindly for watching. Be creative, have fun. See you in the next one. Bye-bye.